Welcome students in this session of Physics New Era channel. Today we are going to know about something different subtopic which is a basic one. Before that one, here it is the Physics New Era by Wadner. Welcome to our channel. Do subscribe to our channel and like the channel. Next to that one we have the Telegram link I am going to provide you. That link gives us a PDF notes. So accordingly do get that notes in the form of PDF. So let us come to the today's subtopic, that is heat capacity, specific heat capacity and molar specific heat capacity. Let me explain the heat capacity definition first. That is, it means heat capacity, it is applicable for the body, whereas specific heat capacity, it is applicable for the unit mass of a substance. So this is most important and nothing else it is given. Just I'm going to raise the temperature of a body by 1 unit, that is 1 degree Celsius. So amount of heat absorbed or rejected to change the temperature of a body, this is most important, body, by 1 unit, that is 1 degree Celsius or 1 Kelvin, is known as heat capacity of that body. So it is heat capacity related to the body to rise the temperature by 1 unit, that is 1 degree Celsius or 1 Kelvin. So similar definition, but it is related to the unit mass of a substance. Once again, amount of heat absorbed or rejected to change the temperature of a unit mass of a substance by 1 unit, that is 1 degree Celsius or 1 Kelvin, is known as a specific heat capacity of a unit mass of a substance. Now let us understand that one. Here example is before you. Let us take the body A. This is the body which is a metal one, and the which is of 5 kilogram, and obviously which is kept at a room temperature, that is 25 degrees Celsius. I am going to rise the temperature of this body by let us consider 5 degrees Celsius, means next temperature is, means we are going to rise from 25 degrees Celsius to 30 degrees Celsius. So let us consider the B body also, but before that one, how much is the energy we need to rise the temperature from 25 degrees Celsius to 30 degrees Celsius, that is 2500 joule. So next to that one, if I need to consider, here it is the another body B, which is a bigger one, which is having the weight of, we say 10 kilogram, and again going to rise the temperature by same, that is 25 degrees Celsius to 30 degrees Celsius. So obviously if we compare the body mass is twice, so energy needed is double. So 5000 joule I am going to provide so as to rise the temperature, that is same, that is by 5 degrees Celsius. So this is the basic formula for the heat capacity. C is equal to delta Q upon a delta T. What is this delta Q? Is the amount of energy provided to the system to rise the temperature, that is delta T. So here it is, if body A I need to consider, body A is having the capacity, that is heat capacity that I need to calculate. I am providing 2500 joule of energy to rise the temperature by 5 degrees Celsius. So accordingly 500 joule per Kelvin is nothing but a heat capacity of body A. What about B? Similar, here it is Cb is equal to delta Q upon delta T, which is nothing but I am providing the energy, that is 5000, and rise in the temperature is 5 degrees Celsius. So accordingly 1000 joule per Kelvin is nothing but heat capacity of a body B. In such a simple language, here it is the specific heat capacity before you. So I am going to modify the equation 1 so as to get the energy. That energy can be calculated, provided energy, if the heat capacity it is known. So delta Q is equal to C into delta T, this general formula. Seems to be I am going to remember this equation 1 as well as equation 2. So here it is the heat capacities before you. There are two heat capacities, depends upon the pressure and volume. First is a heat capacity at constant pressure, that is indicated with a Cp, and heat capacity at constant volume, that is indicated with a Cv. So amount of heat absorbed or rejected to change the temperature of a substance by 1 unit is known as we say specific heat capacity of a substance. 1 unit means obviously 1 degree Celsius or 1 Kelvin. Similarly, at constant pressure is very important, because heat capacity at constant pressure depends upon the pressure and volume, already I had told you. So the next is heat capacity at constant volume. The amount of heat absorbed or reject to change the temperature of a substance by 1 unit, that is 1 degree Celsius or 1 Kelvin, is known as a specific, or we say heat capacity of a substance at constant volume. So this is your heat capacity at constant pressure and heat capacity at constant volume. So accordingly, I am going to give you the molar specific heat, which is most important. Molar name itself indicate it is applicable for 1 mole of a gas. Obviously mole is related to the gas, that's why 1 mole, that means it is clearly applicable for the gases. So the amount of heat absorbed or reject to change the temperature of a 1 mole of a gas by 1 unit is known as, 1 unit means 1 degree Celsius or 1 Kelvin. That means it is a molar specific heat. So molar specific heat indicated with a small c, which is given by heat capacity, that is capital C, upon molar mass. So already we have calculated the C value, that is delta Q upon delta T, substituted here, and we are going to get once again the modified formula. So molar specific heat is also known as a principal specific heat. So on the basis of that one, here I am going to tell you that specific heat, that is capital C, is equal to mass if it is taken in the left hand side, that is small c into m. That means capital C is equal to molar mass into principal specific heat. This formula we are going to remember for the next session in Mayer's relation. So that's why this basic video it is made, so as to understand where from this formula came. So this is your basic formula that we are going to utilize in the Mayer's relation. This is general formula, that is C is equal to m into small c. Similarly, at constant pressure I am going to give, we say Cp is equal to molar mass into principal specific heat. So similarly Cv, that is specific heat, is equal to m into Cv. This is your the formula that we are going to utilize in the next session. So this is most important, you will have to remember this. Thank you.